Part 2 here. I just got done on part 1 talking about the unit circle and how to get the answers for the unit circle. The reason is, the first part, no calculator, solve the following equations from 0 to 2 pi. Basically, these are just asking you to find the angle whose x or y coordinate is given on the problem. So, for example, part A, number 1, sine inverse. So it's asking what angle, right, because that's what sine inverse means, what angle on the unit circle would give me a y coordinate of negative square root 2 over 2. So here's the thing, negative values for sine. Remember sine, can I go up here? Yeah, I can, sweet. No, I can't. Never mind. I'll try and draw small over here. So in our axis here, we have positives, negatives, and we know sine goes with the y coordinate, so sine is positive here. So our answer has to be down here in quadrants 3 and 4. And if you know the unit circle well enough, square root 2 over 2 is some form of a 45-degree angle. So we're at 45 degrees from each axis here and here. So we need to know what is that angle, what is that angle. And those angles happen to be 5 pi over 4 and 7 pi over 4. B is just, they're trying to throw some terminology at you. Arc cosine, remember that's just the same as saying cosine inverse of a half. So here now we're asking, hey, where is cosine? What angle gives cosine equal to positive a half? So what we know about cosine is that it's positive. I'll just leave this quadrant thing up here. Cosine is positive because it's in the x-axis, it's corresponding to the x value. Cosine is positive in these two quadrants, 1 and 4. So cosine is a half based on our unit circle at pi over 3, which is this angle up here, but then it's also the corresponding angle all the way around here, which is 1 pi over 3 away from 2 pi. So that would be 5 pi over 3. Here we have arctan, or tan inverse of 1. So where on the unit circle, what angle gives us a tangent of 1? And the first time we see that, right, is tangent's positive here and here, 1 and 3. So the first time we see tangent equal to 1 is pi over 4. And the next time we see it is straight across from that at 5 pi over 4. So if I'm boxing answers here, this is what it looks like. Okay. Same thing, we can just keep going. Part D, arc sine, which is just sine inverse of negative a half. So let's see. Sine is negative, again, sine is negative down here and here. So where is sine equal to a half? And then we'll put that into the negative, into the right quadrant. So let's see, that would be, well, it's pi over 6 here to give us a positive. So that's over here, that's kind of our reference angle of pi over 6. But since we're down here, that's all the way around 6 pi over 6 plus another, so that's 7 pi over 6. And the other reference angle right here is, well, 12 pi over 6 would be all the way around the circle, right? 2 pi. So if we went all the way around the circle minus a pi over 6, that's 11 pi over 6. And we get to box that in. Now, this is just asking a little differently. It says tangent x is equal to negative square root 3. The first step algebraically would be taking tan inverse of both sides. So this would look like x is equal to tan inverse of the negative square root of 3. All right, so now it looks like A, B, C, and D. So the question is, where is, like, what angle does tangent give us negative square root of 3? And let me clear out some space here. From that previous video I just talked about, you know, what gives us tangent of square root of 3? Well, let's see. First of all, tangent's negative in the second and fourth quadrant, and the larger value gives us a larger angle. So a positive square root of 3 would be, you know, pi over 3 or 60 degrees. But we need to go over here into this quadrant, so we're negative. So instead of a pi over 3 from 0, we're pi over 3 from this reference angle, or just 2 pi over 3. Okay, so 2 pi over 3 is from the 0 all the way around. That puts us in quadrant 2, so the tangent's negative. So the other time that that's going to work is in this quadrant down here. In quadrant 4, we have that same idea that we have this reference angle. So now we need to go all the way around into the fourth quadrant, which puts us at 5 pi over 3. And we'll box that in. So there you go. Question 1, we've totally solved. Question 2 is going to have, again, multiple parts, so I will create a third video on that. Same idea, there's just some algebraic steps to get us to look like these problems in number 1. So.